Welcome viewers, in this video we will see the 4-bit synchronous binary up counter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic 4-bit synchronous binary up counter. So counter is a digital device using for counting purpose from 0 to n or n to 0. Up counter means is counting from 0 to n. Down counter means n to 0. This synchronous means this counter is made up of the flip-flop. Flip-flop is the storage device. It will store 1-bit data. So from that we are performing the counting operation. If the clock pulse is given to all the flip-flops simultaneously, then it is called synchronous. If the clock pulse is given to first flip-flop, the second flip-flop, the clock pulse is the output of the first flip-flop. Like that, if you connect this asynchronous. And here we are using 4-bit. 4-bit means 2 to the power 4. 16 combinations will be there. 0, 0, 0 up to 1, 1, 1, 1. Right? From 0 to up to 16 combination will be available. We'll see how we are getting this 16 combination. So this counter is made up of flip-flop. This counter is implemented with the negative edge triggered flip-flop. There are two types available, positive edge triggering and negative edge triggering. During the clock pulse, I will explain what is positive edge and what is negative edge. Negative edge means going from 1 to 0. When the clock pulse goes low, we are triggering. That is called negative edge. When the clock pulse going from low to high, that is called positive edge. The output of f of naught, that is the first flip-flop, q naught, changes on each clock pulse as the counter progresses from its original state to final state and then back to the original state. So our requirement is first flip-flop output should be continuously toggle on each clock pulse. That is our requirement. We will see how it will toggle. To produce this operation, the flip-flop is f of 0, that is first flip-flop, must be held in toggle mode by constant high on its J0 and K0 input. So for this requirement, what is needed? It should be continuously toggle, so that these two inputs J0 and Q0 is always given as high input, always connected to logic high, right? So that we are getting toggle. So this we see this logic diagram. Here we are using the JK flip-flop. There are, because of 4-bit synchronous binary up counter, we are using 4 JK type flip-flop. What is the nature of JK type flip-flop? If both the inputs are high, J as well as K is high, means the output will toggle. The next state and present state and next state toggle. 0 means 1, 1 means 0. See this in the first flip-flop, J0 and K0 is connected logic high. So every clock pulse, the output will toggle 0 to 1, 1 to 0. So J0, K0 equal to always logic high. So every clock pulse, the output toggles 0 to 1, 1 to 0. That is the main requirement. In order to get the up counter, the first flip-flop output should be toggled so that high output is connected always to the first flip-flop, J0 and K0. What about the second flip-flop? The output of first flip-flop, Q0 is connected as J1 and K1 input of the second flip-flop. So whenever Q0 is 1, this Q1 will toggle. When Q0 is 0, there is no change in the output. So J1 and K1 is nothing but output of the first flip-flop, Q0. Based on the Q0 value, Q1 value will change. Q1 will toggle whenever Q0 is 1. Then the third flip-flop, J2 and K2. It is connected through the AND gate, Q1 as well as Q0. Both are connected. If both are high, then only we will get the high output here, J2 and K2. So whenever Q1 as well as Q0 are high, 1 will be applied to J2 and K2 so that the output Q2 will toggle, right? So the output Q2 will toggle whenever J2, K2 is 1, that is Q1 and Q0 should be 1. If any one is 0, there is no change. Both should be high, then only toggle. Then the fourth flip-flop, J3 and K3. Again one more AND gate is connected. That is nothing but Q2 as well as this output. This output is nothing but Q1 and Q0. So Q2, Q1, Q0 is connected in the AND gate. So all three Q1, Q2, Q0 should be 1. Then only this J3 and K3 will be 1. Then Q3 will toggle. Right? So output of fourth flip-flop Q3 depends upon Q2, Q1 and Q0 all should be high. If any one is low, the output will not change. Right. So this is the connection of 4 flip-flop. First flip-flop receive logic high always. So during every clock pulse the output toggles. Second flip-flop based on Q0. So whenever Q0 is 1, output toggles. Q0 is 0 means output not changes. J2, third flip-flop, is based on Q1 and Q0. Whenever Q1 and Q0 both are high, this output of third flip-flop will toggle. Any one is 0, no change. Fourth flip-flop is connected through Q2, Q1 and Q0. Whenever all these three are high, then output toggle. Any one is low, output will not change. So this is the connection. Now we'll see the clock diagram. So Q0, Q1, Q2, Q3 is the output. This is LSB and MSB. So here clearly given J0 and K0 is 1. J1, K1 is Q0, output of the first flip-flop. Q1 into Q0 is the input to the third flip-flop. Q0, Q1, Q2 is the input to the fourth flip-flop with AND operation. Right. Now we'll see the clock diagram. Based on our connection, we'll see how we are getting this 16 combination of output. So this is the clock pulse available. It's a clock pulse. This is the output of Q0, Q1, Q2 and Q3. This is the states. 16 different states are available. 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1 like that. This is MSB and LSB. So this is the clock pulse. We already know that we are connected with the negative edge. Inverted clock pulse is connected through inverted clock pulse, negative edge. What is meant by negative edge? We will see that. Negative edge and positive edge. So here the clock pulse is low, here high. Changing from low to high. This is the positive edge. After this is the high to low. Clock pulse is high here, it goes to low. So this is the negative edge. This one is positive edge. When the clock pulse is directly connected, whenever there is a positive edge, the state will changes. But here connected with inverter, whenever goes down from 1 to 0. So these are all the negative edge. When the clock pulse going from high level to low level, right? If it is other end means positive trigger. This one is negative trigger. Whenever it goes low, right? See this, when the clock pulse is going low from high to low during this negative edge, the changes. Initially all are 0, changed from 0 to 1. Again, the next negative edge, 1 is changed to 0. Then 0 to 1. Then here 1 to 0, 0 to. So every negative edge, the state is changes. 0, 1, 0, 1 like that. Because first flip-flop always connected with high input. J0 and K0 is high. So every clock pulse, the state of the flip-flop toggles from 0 to 1, 1 to 0. So this is a negative edge, inverted edge, right? Now we'll see the Q1. Q1, what is the input? Q0 is the input to the second flip-flop. So based on this input value, the Q1 output of the second flip-flop will changes. See here it is 0, initially 0, so no change. Here 1 is there, 1 means toggle. So 0 is toggle to 1. Here again 0, no change, 1 is maintained as it is. Here 1 means toggle, 1 is toggle to 0. Here 0, no change, 0 is maintained as it is. 1 means toggle from 0 to 1. Again 0, no change. 1, toggle from 1 to 0. 0, no change. 1, changed from toggle from 0 to 1. 0, no change. Like that it goes. So whenever there is a 1, the toggle will occurs for the second flip-flop. What about the third flip-flop? Third flip-flop is based on Q1 and Q0. Both are connected through the AND gate. Whenever both are 1, then only toggle will occur. If any one is 0, no change. So initially 0, 0, here 1, 0. This is 1, but this is 0, no change. Here 0, 1, no change. Here 1, 1, both are 1. So 0 changed to 1. That will be continue because this is 0, 0, 0, 1, 1, 0, no change. Here again 1, 1. So again changed from 1 to 0. Then again 0 is continued because this is 0, 0, 1, 0, 0, 1, no change. Again it is 1, 1. When 1, 1 occurs, toggle from 0 to 1. Then it is say again this maintain as it is until next 1, 1. Changed from 1 to 0. Right? So this is the output of the third flip-flop. Whenever 1 is there, toggle from 0 to 1. Whenever 1, toggle from 1 to 0. Whenever both are 1, toggle from 0 to 1. Whenever both are 1, toggle from 1 to 0. Right. What about the fourth flip-flop? It is connected through Q2, Q1 and Q0. If all are 1, all three outputs are 1, then only toggle. See here this is 0, 0, 0, 0, 1, 1. Minimum 1, 0 is there. Only here all are 1. Q0, Q1, Q2. So the AND gate output will be 1. So it will toggle from 0 to 1. The same thing maintained because here minimum 1, 1 is there. After this, at this point, again both are, all three are 1. So it is toggle from 1 to 0. Right? So whenever all three outputs are 1, toggle from 0 to 1. Next occurrence of all three 1, toggle from 1 to 0. Now we see this value, we will get the 16 combination. 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. Like that, finally we will get 1, 1, 1, 1. There are starting from 0 to 15, 16 combinations are available. So it is clearly given here. At this point, both are 1, Q0 and Q1. At this point, Q2, Q1, Q0, all three are 1. At this point, Q1 and Q0 is 1. At this point, all three are 1. Right? So based on that, we have received the 16 combination of a 4-bit up counter. So briefly I will explain. This first flip-flop, always input is high, so every clock pulse it toggles. Second flip-flop, it is the input is the output of the first flip-flop. Whenever the output of Q0 is 1, toggles. 1 means toggle, 0 means no change. Third flip-flop, based on these two, Q1 and Q0. Whenever both are 1, toggle. Fourth flip-flop, based on these three values. Whenever all are 3, toggles. All are 3 toggles. Otherwise, same data will be maintained. Now we'll see the description for this. So what we discussed, the details are available. The output of f of 1, that is second flip-flop, goes to opposite state following each Q0 is 1. Q0 means first flip-flop. When the first flip-flop output is 1, the second flip-flop, the toggle, it will toggle. To produce the operation, Q0 is connected to J1 and K1 inputs. That we already know that. When Q0 is 1 and clock pulse occurs, f of 1, that is second flip-flop in the toggle mode, thereby changing the state. Right. When Q0 is 0, flip-flop 1 is in the no change mode and remain in the present state. Right. So second flip-flop based on the output of the first flip-flop. Q0 is 0 means same state. Q0 is 1 means toggle. For third stage, the flip-flop has to change when the state is Q0 and Q1 is 1 because we connected through AND gate. Both are 1 mean flip-flop f of 2, that is third flip-flop toggles. And for all other time it is in the no change condition. If any one is 0 means no change. Both are 1 means toggle. For the fourth stage, flip-flop has to change in the state when Q0, Q1, Q2, all three are 1. This condition is decoded by the AND gate G2. Thereby, when Q0 equal to Q1 equal to Q2 equal to 1, flip-flop F of 3, that is fourth flip-flop toggle. And for all other time, there is no changes. Right. So this is what we discussed. It is clearly given in the statement. Points where the AND gate outputs are high are indicated by the shaded areas. That already in the timing diagram it is clearly given. So in this video we discussed 4-bit synchronous up counter. There are 16 combination. We discussed the logic diagram followed by timing diagram and description. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.